All right, rectangles. The cool thing about rectangles is they also are parallelograms with two more properties. So, remember when we talked about, here we're going to put properties of rectangles. So, not only does it have the properties of parallelograms, like the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other, but there's two more properties. Well, we know that rectangles have what? All four angles are right angles. Now, the key thing about diagonals in rectangles, not only do they bisect each other, but the diagonals are congruent. Being congruent is not the same thing as bisecting each other. Bisecting each other is where they cut each other in half. But they're not necessarily the same length. But in rectangles, not only do the diagonals cut each other in half, but they're also congruent. So we can write some really cool equations for that. Well, using these properties, well, see how we said QR, opposite sides are congruent? So if PS is 10, QR is 10. SR, which is this side, is opposite PQ, so we know it has to be 24. SQ is the whole diagonal. We need to figure out, how do we figure out SQ? Well, guess what? We don't know PR. If we did, we could say, well, these both are going to be the same, right? Because we said all diagonals are congruent. Well, what do? Well, our trusty little, we'll just use one right angle, since we know a rectangle has four, and we're going to use the Pythagorean theorem. Fun times. And we know SQ is the hypotenuse because it's opposite the right angle. So basically we're going to do 10 squared plus 24 squared equals, I'm just going to call it C squared for the hypotenuse. So C is going to represent SQ. Oops, I didn't write it. So that's 100 plus, I don't know, I'm just going to tell you, it's 676 equals C squared. You square root both sides, and C is 26. So if this diagonal is 26, the other diagonal, PR, is also 26. So just like when we did in our circumcenter and centroid and all that jazz, we have to use pieces of the diagram with right triangles in the Pythagorean theorem. Now let's look at QT. Well, remember we said that the diagonals bisect each other and they're congruent. So guess what? All four of these little tiny half diagonals are also going to be congruent if the two long diagonals are congruent. So basically each diagonal we just cut in half. So that's 13. Okay, so you're going to use that to do number 2. Now on number 3, remember opposite angles are congruent, but also because opposite sides are parallel, we can do alternate interior angles. And guess what? Since we know this is 27, this has to be 27, which is JLM. All right. Do they even want to know that? Nope. Oh, nope. Okay, well, it might help us at some point. Okay, MJK. So MJK, guess what? MJK is a right angle, so that's 90 degrees. MJL, well, guess what? If this piece is 27, but the whole angle for MJK is 90, we just do 90 minus 27. Well, 90 minus 27 is 63, okay? Well, if this is 63, this angle, because this side is parallel to this side, this angle has to be congruent to this angle. So this is also 63 because of the transversal. They're alternate interior angles according to this transversal. Well, this angle, what is this, KLJ or JLK? Oh, this one is also 63, okay? All right, KML. So we need this guy. And, oh, guess what? I just saw a shortcut. Remember what I said about all these little guys are congruent because the diagonals bisect each other? Look at this. Do you remember when we talked about isosceles triangles? Well, if this is 27, this is also 27. And do you remember with isosceles, so if I just look at this triangle right here, because these sides are congruent, guess what? These base angles are also congruent. So this angle, which is essentially KML, because we can extend that side, even though we're only using the isosceles triangle from NML, has to also be 27. Okay. Now let's look. Okay, they want angle MNL. Oh, well, let's just use the same triangle. Since we know that the three angles in a triangle is 180, I'm just going to do 180 minus 2 times 27, since both base angles have to be 27. I didn't bring my calculator! Oh well, I'm just going to tell you. This equals 126, so that's 126. Okay, so try number 4 on your own. Now, since they tell you that DB, which is the whole diagonal, so I'm just going to write diagonal, is 42, and they tell you that AD is 26, and they tell you that the angle, actually let's not worry about the angle for a second, let's finish these sides. They want AC. Well, isn't AC also a diagonal? Since DB is 42, then AC also has to be 42. EB, remember we said that these little pieces in a rectangle are congruent because the diagonals bisect each other and they're congruent. So basically we just take the diagonal and divide it in 2. So EB and all these other little half pieces have to be 21. Well, BC is opposite 26, and so it has to be 26 as well. Now, how do we find AB? Remember we said we could take a piece and use the Pythagorean right triangle? Well, that's exactly what we're going to do, because this is a right angle. Anyways, we already said the diagonal, the whole diagonal is 42. I'm just going to draw the little right triangle here. So this is 26, this is 42, so we're trying to find AB, so I'm going to call that X. 42 is the hypotenuse. I can't talk today. What's new? So 26 squared plus x squared equals 42 squared, 42 squared. Basically solve for x. I don't have my calculator, but I'm going to tell you x is 33. Everybody at this point should be able to do the Pythagorean theorem. If not, come see me. Yeah. So now let's deal with all the angles. Okay. So DAE. This piece right here is 52 degrees. Well, guess what? Automatically, this angle and this angle, because these sides are parallel, this also has to be 52. So let's see if that's any one of them. Do we have ACB? No, of course not. That would be way too easy. Whatever. But because this is a right angle, we can do 90 minus 52, and we know this piece. But if we know this piece, we know this one. And this is an isosceles triangle, so we also know this. And this is another isosceles triangle, so we know this. And actually, this is also an isosceles triangle. So if this is 52, this is also 52. This is also an isosceles triangle. So if this is 52, this is also 52. So essentially, all we really need is 90 minus 52, which is 38. So guess what? All these little pieces are 38. Okay, now let's just see which ones they want. So A, D, oh, C. We know that's 90 degrees. A, D, C, because that's the outside. Hello, I should have looked at that sooner. Okay. A, B, D. Well, we figured that out. It's 38. Okay. B, C, A, we know is 52. D, E, C. Now remember we said, let's use this isosceles triangle. And basically we're looking for this angle for DEC. Well, we know these two angles are 38. So, actually I'll just do this. We know the angles in a triangle is 180 minus 2 times 38. Well, I'm just going to tell you that's 104. Okay. I didn't bring my calculator, but I have the answer key. Okay. Now, let's look at the backside. Okay. Oh, sweet. This one's easy, I can already tell. To find EF, well, we know since a rectangle has the same properties of a parallelogram, they're congruent. So guess what? We're just going to say, well, 3x plus 5 has to equal 7x minus 39. I'm really in a don't want to solve math mood. Sorry, guys. So subtract 3x, add 39. 7 minus 3x is 4x. I'm just going to switch sides again. And 5 plus 39, 44 divided by 4. X is 11. Hallelujah. Well, but that's not what they're asking for. They didn't ask for x, did they? Nope. So we have to do an extra step. Oops, what did I drop? Oh, my water bottle. Okay. Now we got to plug it in to find EF. So basically EF is going to equal 7 times 11 minus 39, or 77 minus 39. That's 38. Hallelujah. Okay, now look at number 7. It says RT, which is a diagonal, so this is a diagonal, and US, which is also another diagonal. Oops, diag for diagonal. Well, we know that the diagonals are congruent in a rectangle. That's unique to a rectangle, not parallelograms. So we basically can set 5x minus 14 equal to 2x plus 10. Now to find VT, basically once we find x, we got to plug it into one of these and divide by 2, since VT is this half and we know the diagonals bisect each other and are congruent. So subtract 2x, add your 14. So 3x equals 24, mental math, x is 8. We got to plug it in. I'm going to do this one. So all of US equals 2 times 8 plus 10. Well, 16 plus 10 is 26. We only want, VT, but it doesn't matter which one we find because they're both congruent. So I'm just going to say, well, 26 divided by 2 and VT is 13. Okay. Notice this. JM is just one of the halves of the diagonals. And then they give you MK, which is another half. Well, guess what? These are equal. So x plus 17 has to equal 5x minus 23. Subtract x, add 23. 5x minus, or 5x minus x is 4x. 17 plus 23, what is that, 40? So x is 10. But we can't stop there because they want to know JL. Well, JL is the whole diagonal. So if we plug in x for one of these, which I'm going to use the easier one, like JM, we just double it to find JL. So I'm going to do this. JL is just 2 times JM, or basically 2 times, if you plug in 10 for x, 10 plus 17, that's 27 times 2, what is that, 54. Okay. So here they're talking about VW and SU. Well, SU is the whole diagonal, and this is just half. Ugh, that looks really messy. So one way you could do it, either 2 of these equals this, or half of this equals... I'm gonna, say half the diagonal. So this equals 1/2 this, or I prefer to saying the big piece equals 2 of the smaller pieces. So 16x minus 12 has to equal 2 times 9x minus 11. All right. And guess what? WT is going to be the same thing as VW. So I'm just going to tell you x is 5. So I'm actually going to, so VW has to equal the same thing as WT. So I'm just going to use this, do 9 times 5 minus 11, that's 45 minus 11, which is 34. Okay. Okay, on to the angles. Guess what? Right away, opposite sides are parallel, so these are alternate interior angles. So guess what? These are equal. So 7x plus 5 has to equal 11x minus 3. I'm just going to tell you for time's sake, x is 2, because the key is being able to write the equations, like we've always talked about. But we need to find B, C, E. So basically we need to plug in 2 and find this, and then subtract from 90 to find this piece, B, C, E. Well, it doesn't matter. I'm just going to do the 11 minus 3. So 11 times 2 minus 3, well, that's 22 minus 3. That's 19. So if this is 19, then the measure of angle BCE has to equal 90 minus 19. Excuse me. So the measure of angle, okay, BCE has to equal 71. Boom. 90 minus 19 is 71. Ooh. See this? Automatically, these make up a right angle. So this plus this has to equal 90. So I have 3x plus 2 plus 12x minus 17 equals 90. 3x and 12x is 15x. 2 minus 17 is negative 15. Oh, add 15 divided by 15. Oh, I'm just going to tell you x is 7. But they want to know what J... Wait. Oh, this is an L. Oh, that's an I. I can't see. One day you'll be blind like me. No, I'm just kidding. I never thought I'd be blind, and now I am. Okay. JHI. Well, guess what? This angle is congruent to this angle. So I'm going to plug it in because of these sides are parallel. So I'm just going to plug it into the 3x plus 2. Not this one. Don't plug it into the wrong one. So again, JHI, this angle, is alternate interior to this one with the parallel sides. So they're congruent. So the measure of angle JHI has to equal 3 times 7 plus 2. Well, that's just 21 plus 2. So that's 23. Okay. You know, I just want you to see something. Maybe you haven't seen this yet. If I know this angle and this angle, I would automatically go for a right triangle. And since all three angles in a right triangle have to be 180, and we know this is 90, then this plus this has to equal 90. We don't even need that. So we're just going to do that. 5x minus 8 plus x plus 20 has to equal 90. So 6x, and then that's plus 12, equals 90. So subtract 12, 6x equals 88. No, I'm sorry, 78. No, wait. Yeah, 78. I can't think tonight. Divide by 6, and x equals 13. But of course, that's not enough. They want to know what is x, z, w. Remember what I said about alternate interior angles? So this one has to be the same as this one because of these parallel sides, because these two angles are alternate interior. So I'm going to plug into x here, not here, to save myself time. So the measure of angle XZW has to equal 5 times 13 minus 8, 50 plus 15, so 65 minus 8, I can't think, 57. Okay. We love parallel lines, and I've always talked about how since these parallel lines always imply congruent angle pairs unless they're alternate interior. Well, all right, to solve for x, guess what, guys? There's a few things we could do. Well, if this angle is 5x plus 7, guess what this angle is? Also 5x plus 7. And these are isosceles triangle. So I could use this 134 and subtract from 180 to find this angle. And then basically 2 of these plus this angle has to equal 180. So that's what we're going to do. Well, first of all, 180 minus 134, 46. So if this is 46, and these two are congruent base angles since it's an isosceles, again, let me draw. So we know that these two sides are congruent because the diagonals bisect each other. So these base angles have to be the same. So we can just say that 2 of the 5x plus 7s, which are the base angles, plus that 46 has to equal 180 since the angles of a triangle add up to 180. I'm going to go ahead and subtract 46 right away. And distribute. So I get 10x plus, oops, I was going to write 35. So the 5 and the 7. 14 equals, what is that? 134 minus 14. So 10x equals 120. Yay! X equals 12. And we can stop there! Yay! Okay, good job. Now I'll work on the homework. Okay.